So this class, my fifth period is farther ahead. So we're just going to jump in at on example 4, since we only got through examples 1, 2, and 3 yesterday. So it says we have a group of friends who are on a camping trip. They decided to go on a hike. So we have 1 mile between trail 1 and the campsite. And then there is 1.5 miles between trail 1 and 2. And then 2 miles between the camp and trail 2. So it looks like we have trail 1, trail 2, and a camp. So let's go ahead and draw a triangle. I don't know why I drew it upside down. I really don't have a reason. Doesn't matter. So I'm going to call this trail 1, and this one is trail 2. So now we're filling in our numbers. So it's 1 mile between trail 1 and the camp. So trail 1 and the camp, that would be this side. So we're going to put a 1 right there. Then there is 1.5 miles between trail 1 and 2. So I'm putting 1.5 there. And then lastly, we have 2 miles between the camp and trail 2. Okay. So let's figure out what exactly they want us to find. It says, find the angle that is formed by the 2 trails that lead to the camp. So I'm going to number these or letter these, and you just tell me which one you think. I'm going to call this A. I'm going to call this one B and this one C. So who thinks we're looking for A? Who thinks we're looking for B? Who thinks we're looking for C? It is B. Good job. So we have to figure out where and what angle is formed by both trails. Both of these angles here, both of these pathways connect to the trails. So we're looking for this. So we're going to set up the law of cosines. So because I'm looking for an angle X, I'm going to start with the side opposite. So what's the length of the side opposite from angle X? 1.5. So we're going to start off with 1.5 squared. And then so we're not going to use 1.5 in any other place. The rest is just going to have a 1 or a 2. So that's going to equal the other 2 sides squared minus 2 times those 2 sides. And we're going to end with the cosine of X. So remember, like we said yesterday, it is very important that you separate this into 3 separate numbers. I can guarantee you on the test next Thursday, I'm going to have at least 5 students try to put this whole thing in their calculator and come up with one number. You can't do it. You have to chunk it into pieces, and we have to solve it. So I'm going to freeze my screen, and then we'll see if we get the same answer at the end. Okay, let's see what answers we coming up with. Oh, is that a Spanish? Oh, okay. I thought it was a 9. Wow, y'all getting fast at this. So put the cosine back right here. Erase. Yeah, and the line under that.
Oh, I divide by negative.
Yeah, you gotta divide by negative here. Then, because you're looking for an angle, you have to take the inverse. That's okay. This don't forget that this is still negative. So put the negative down there. And the negative is still there. That was not bad. That was not bad at all. I'll give you a moment to look at my answers, how I solved it out. So my answer was 46.567 degrees. Any questions? Pretty good? All right, we are actually going to skip 5 and go directly to 6. So let's go to 6. So we have a father that's holding a kite at an angle of 72 degrees relative to the ground. The length of the string is exactly 20 feet long. Looking up at the kite, his son is standing 19 feet away from the dad. Calculate the distance between the kite and the sun. Okay. So I'm not going to try to draw dad. I'm just going to say dad and son. And the dad has a string attached to a kite. And the angle formed, again, so this is relative to the ground. So this is my ground, my little nice green grass. That angle is 72 degrees. The length of the string, so remember, this is where my string is. This red line is my string. The length of that string is 20 feet. And then it says that the dad, he is standing 19 feet away. So this distance, I'll make it a dash line, not that it matters, is 19. And what we're trying to figure out is how far away the distance between the kite and the sun. So here's my kite, and this is the sun. So this is what I'm looking for. Now, we can use the law of cosines, but because we're looking for a side, We can actually just type it in the calculator in one step, all under the square root. So x is going to equal, I'm going to go ahead and freeze my screen. You go ahead and do it. So we're going to start with the sides we know. So it's going to be 19 squared plus 20 squared. X squared equals 19 squared plus 20 squared. Yeah, I'm trying to see. Yeah, I'm gonna see that. Oh. Okay. You forgot to put in the cosine. Oh. The cosine of the angle. Let me make sure that's right. I think you gotta put a parentheses at the end. Yes. All right, go ahead, take a moment. So I got 22.938 feet. Anybody else get that? All right, pretty good. I know the law of cosines looks scary, but it's not so bad. Not so bad at all. All right, so let's look at example 7. So we have a lifeguard that leaves the port to rescue 2 swimmers. The lifeguard swims towards the first swimmer and travels 38 feet. So the lifeguard to the first swimmer is 38 feet. Then he's going to go directly to the second swimmer and travel 49 feet. And then all three of them return to the port, which is 20 feet away. So what we have here, we have a port, we have the first swimmer, we have the second swimmer. We got our triangle. So it says the lifeguard goes 38 to the first swimmer, and then from the first swimmer, he goes to the second one, which is 49 away, and then they come back to the port, which is 20 away. So it says from the original position of the first swimmer. So again, this is where we're talking about. Calculate the angle between the lifeguard and the second swimmer. So they want the perspective from the first swimmer. So this is where we're looking for. This is the angle I'm looking for. I'm looking for the angle next to swimmer 1. So we're looking for an angle. So we got to set it up. We got to solve it. So what do I start off with? 38 squared, 49 squared, or 20 squared? Which number do I start off with? It has to be the one opposite of x. So which side is opposite from x? 20. So we're going to start off with the 20. And we're not going to use that number 20 at all anymore. We're going to set that equal to the other two sides squared. And then it's minus 2 times 38 times 49, and we're going to end with the cosine of x. So again, we have to solve it. So we have to break it up to 3 pieces. think that's the number that's wrong. So type in inverse cosine. Put it in as a fraction. 34, 45. Yeah. So, yeah. What is the point nine two five?
Wait, the same is?
Yeah.
Oh.
I just don't know why you had the 0.925 there at first. So just leave it as a fraction. It's more accurate that way.
Okay.
All right. Who agrees with my answer? 22.319. All right, we got our last question. I want you to read it and draw your triangle by yourself, and then we'll talk about the method we're going to use. So read the question, draw your triangle out. We got a post that's supported by two wires, one on each side going in opposite directions, creating an angle of 80 degrees between the wires. The ends of the wires are 12 meters apart on the ground, and one wire forms an angle of 40 degrees with the ground. So I'm going to see what these diagrams look like. Wires to go to the ground. Is the ground up here?
No.
No, the ground is in the sky. That looks good. So now you have to figure out which one you're going to use, solve sines or cosines. Yep. That looks good. Okay, so this is, that little purple box is my post. Okay, so we have a post, and that post has two wires attached to it, going in opposite directions. It tells us that it creates an 80-degree angle between the wires. So since my wires are coming together right here, that's where I'm going to put my 80-degree angle. 80 degrees. And then it tells us that the wires are 12 meters apart. And one of the wires forms an angle of 40. So now that doesn't matter. If you put the 40 here or here, it doesn't matter, because it doesn't say that it's attached to the first wire or the second wire. So it doesn't matter. You can put it with the red wire. You can put it with the blue wire. I'm going to put it with the, I'm going to put it over here. That's where I set it up. They want us to find both wire lengths. So they want us to find this side and this side. So the first thing you have to figure out is which law are we going to use? Are we going to do SOHCAHTOA, law of sines, law of cosines? Like, what are we going to do to get these two answers? What y'all think? Law of sines, because we have our opposite. I know that across from the 80-degree angle is 12 meters. So I have my pair. This is my opposite pair. So I'm going to set it up as the sine, law of sines is because we have an angle side pair. That is why we are using the law of sines. So I'm going to set it up as sine of 80 over 12 equals, oh wait, before we get started, how do we find this angle? If this is 80 and this is 40, what would this one be? 60. We're going to do triangle sum. We're taking 180 minus 40 180 minus 80 minus 40. So that leaves us with 60 degrees. Okay, so now we're ready. So when I'm trying to find x, I'm going to use the sine of 60 because that's opposite of my wire x. That's going to be your first proportion. Go ahead and cross multiply and solve it. And then you're going to do a second proportion. Well, you'll have the sine of 40 over y. So go ahead and solve both of those to get your two lengths of your wires. Oh, it's not feet, it's meters.